Alright, so this is your video on order of operations, and we first want to remind you about the pyramid of power.
Cool.
P stands for parentheses.
E stands for exponents.
You're used to hearing PEMDAS, but the pyramid of power is important because multiplication doesn't always occur first in the order of operations problems you're going to work out. Whichever is on the left is the operation that should be performed first. It is okay to divide first if it is on the left side. So don't forget, multiply or divide.
And then lastly, addition or subtraction. And just like Mr. Turner said, you want to perform the operation that is on the left side first.
Let's try a practice problem. First, we want to consider whether we should multiply or divide, and we determine the first operation based upon what is on the left. This problem contains multiplication and division. We're going to perform division first because it's on the left. I'm going to show you one step at a time, one step per line, keeping in mind that my work will get smaller towards the bottom. It should look like an ice cream cone. Since it's on the left, 8 divided by 2 is 4, and I'll use the rest of the problem without making any changes in the first step. So I have subtraction, I have multiplication, and I have addition. It might be helpful for you to use the definition of subtraction, which says add the opposite. I'm multiplying a negative times a negative, which is going to result in a positive. 2 times 3 is 6. I copy the rest of the problem. I'm working from the left and going to the right. 4 plus 6 is 10. 10 plus 1 is 11.
Alright, in this next problem, we're going to look at a few different things that we did not see in Mr. Turner's problem. In this problem, we have some exponents, and as well as some problems being done inside of the parentheses. In this problem, what we look at first from the pyramid of power is parentheses first. You see, when we look at this problem, we have a 2 plus 10 inside of a parenthesis. You also see that we have things that we call brackets. They're almost like a second set of parentheses. We're going to start with the first set, pulling down just as Mr. Turner did, one step at a time. 4 minus 2 squared. Inside the parentheses, 2 plus 10 gives us 12. Pulling everything down just as we see it. The next step that we see here is the second set of brackets that we need to get rid of. Like I said, it's another set of parentheses. So inside here we have 12 divided by 6, which is 2. That lets us get rid of the parentheses around the 12. Pull everything else down just as you see it. The next step that we see is exponents. Exponents comes next in our pyramid of power. Our exponent that we see is 2 squared. 2 squared is saying 2 times 2. 2 times 2 is 4. And then we follow everything down again, just as we see it. The next thing that we have in pyramid of power is the M or D, multiply or divide in the order from left to right. In this, we only have multiply. 4 times 2. 4 times 2 is 8. Pull down everything else just as you see it. We now have subtraction and addition left.
We can use subtraction or
divide
addition.
going from left to right, starting with the left side. 4 minus 8 is a negative 4 plus 5. We now have 4 negatives and 5 positives. When we put them together, we get a positive 1.
Alright, in this example, we have a lot of things going on here. We have a double set of parenthesis and bracket, or like a nested parenthesis, as well as multiplication and some exponents. The pyramid of power requires that we take care of what's inside the parenthesis first. So I'm just going to focus on this parenthesis right here. And I see that I have 10 plus 2 to the third power. Now, I need to take care of the operation inside the parenthesis, which is addition. However, I have an exponent here, and I have to take care of exponents before I take care of addition. So the first thing that I'm going to do is rewrite 2 to the third power. 2 to the third power is the same thing as 2 times 2 times 2, or 8. And then I'm just going to actually show each step, so I'm going to rewrite every single bit of this problem again. So all I've actually taken care of is the 2 to the third power. Okay, so now I can do what's inside this first parenthesis, or this nested parenthesis, and I have 10 plus 8, which is 18. And then again, I'm going to rewrite the problem.
What happened?
Alright, so I have 16 divided by 18 inside this parenthesis. And actually, I'm going to write this as a fraction. So when I look at the fraction 16 divided by 18, I see that I can reduce that fraction. I'm going to divide by 2 on both of these, and when I do that and I rewrite this, 16 divided by 2 is 8, 18 divided by 2 is 9. So now I've done my division problem and I have a fraction, and then on the outside I have a negative 5, so negative 5 times 8 over 9 plus 3 squared. So now I need to take care of the 3 squared, this exponent. 3 squared is 9. So I have negative 5 times the parenthesis, 8/9 plus 9. The next order of operations, or pyramid of power, says that I need to take care of multiplication. In order to multiply a whole number with a fraction, the easiest thing is to turn this into a fraction. So that's what I'm going to do. I'm going to show my work and write out the step. I have negative 5 over 1 times 8 over 9 plus 9. When I multiply fractions, I just multiply straight across. You learned from your integer video earlier that a negative times a positive yields a negative. 5 times 8 is 40. So this is a negative 40 over 9 plus a positive 9. Now here, I have a whole number, and the only way that I can add fractions is if the bottoms are the same. The denominators need to match. And this is actually, the whole number 9 is really the same thing as 9 over 1. So I need to multiply this number, 9 over 1, by something so that it has a denominator of 9. And so I'm going to multiply it by 9 over 9. So rewriting the problem, 40 over 9, sorry, a negative 40 over 9, plus, I'm going to go back up here. 9 times 9 is 81 over 9. So now, because my two fractions have the same denominator, I can add them together. I have two integers, or two signed rational numbers, a negative and a positive, so the rules that I learned for integers apply here. Same signs add and keep, different signs, a negative and a positive, different signs subtract. So I'm actually going to do my work right here. 81 minus 40 is 41. So 41 over 9, the denominator stays the same. Keep the sign of the larger number. Keep the sign of the bigger number. The bigger number is positive, 81. So this, in fact, is my answer. That was a challenging one.